Let's continue our journey with rational expressions by looking at how to multiply and simplify. Well, we already know how to simplify rational expressions, don't we? Don't we use factoring to simplify rationals? Yes, we do. So if you guessed that we would be factoring in order to multiply rational expressions, you would have won yourself a prize. So let's go ahead and try that. Let's see what happens when I multiply the quantity x plus 2 over x minus 3 times the quantity x squared minus 4 divided by x squared minus x minus 2. Okay, the first thing we want to do is, can we factor anything here? No. You may be tempted to factor out to cancel out those x's, but remember, you are not allowed to cancel out terms. You can only cancel out factors. So let's not cancel out those x's. This one doesn't change. It's still x plus 2 over x minus 3. Now, that's going to be times the quantity. Oh, look at this. This is the difference of two squares. And if you haven't already found this pattern, you should know that whenever I have the difference of two squares, it is the root plus the root times the root minus the root. The square root of x squared is x, root and root. The square root of 4 is 2, root and root. And plus and minus means that if I were to multiply this out, my two middle terms would cancel. I would get plus 2x minus 2x, and those would add to 0. And so I'm just left with x squared minus 4. And let's take a look at the denominator. That one I'm looking for factors of negative 2 that combine to give me a positive 1. My only factors of 2 are 1 and 2. That one is positive, so that one must be negative. So we have x minus 1 times x plus 2. So now all we have to do is look for any ones that we can cancel out. And it looks like I have x plus 2 and x plus 2 on the top, so I have that twice, and I also have one of them on the bottom. So I can take one of those guys at the top and cancel it with one on the bottom. Do we have any other ones to cancel out? Sadly, no. So what we're left with is, in the numerator, we're left with x plus 2 times x minus 2, and in the denominator, we're left with that x minus 3 times x minus 1. And that would be multiplied and simplified. Looks like we have a little bit of extra time, which is always fun for me. So let's try dividing. Let's divide and simplify. Shall we? We shall. So here's our expression. It is x squared minus 1 over x minus 1, and then we have that divided by x squared minus 2a plus 1 divided by a plus 1. Now remember, when we're dividing any numbers, if we're going to divide c or d, then what we do is we take the reciprocal of the second number and we multiply it. Dividing is the inverse of multiplication. It's the opposite operation of multiplication. So if we just multiply the inverse, it's the same thing as dividing. So really I can rewrite this guy as a squared minus 1 over a minus 1 times the quantity a plus 1 over a squared minus 2a plus 1. Now, let us have our fun factoring. A squared minus 1 is the difference of two squares, so I'm going to say root plus root times root minus root, and all of that goes over a minus 1. Cool beans. A plus 1 is not factorable. And again, this denominator here, is something that you should be able to recognize as a perfect square trinomial, which is to say it is a plus 1 squared, or times a plus 1, right? A times a is a squared. 1 times 1 is 1. If I multiply those two terms and then double it, oops, it's not plus though, it's minus. Thanks for catching that. It is minus. How do I know it's minus? What changed my mind? Well, I'll tell you what changed my mind. What changed my mind was that the middle term is a negative. So negative and negative. All right, so now let's look for ones to cancel. Aha, I have 1 there, and I have 1 there. Is that all? Ah, darn it. That's all. I like when there's lots of 1s to cancel. So in the numerator, we are left with a plus 1 times the quantity a plus 1, because that's what's left up there. In the denominator, we're left with a minus 1 times the quantity a minus 1, and we are done.